All right, so today's lesson is going to be naming ionic compounds with a variable charged metal. So we are going to be on the second page of our ionic naming notes. All right, so what I've done here is I've just rewritten this page for us to look at. When we do a variable charge metal, a variable charge metal is going to be our transition metals, with the exception of zinc, which is a fixed charge of 2+, and silver, which is a fixed charge of 1+. Tin and lead, notice tin and lead are in our 4 column, and if you remember, I said this column, we put the plus or minus 4 just as a placeholder, but it's not really a plus or minus 4. So tin and lead are also going to behave as variable charges. This comes from our element and ion quizzes. Make sure you go back and you review them. The Roman numeral tells us the oxidation number. So copper 2, that is a Roman numeral 2. So that means copper 2 has a number of Cu2+. Now, sulfide is a fixed charge. Sulfide is always 2-. So when we look at this formula, our numbers are the same, and when you have the same number in the cation as you do the anion, you simply rewrite the symbols. All right, let's look at the examples on our worksheet. Copper 1 chloride, copper 1. That tells me that copper is a 1+. Chloride is a 1-. So we have a 1 and a 1. Both of those numbers are the same. I am simply going to rewrite my symbol. Lead 4 sulfide. That's lead 6 sulfide. Lead 6 sulfide. So that is going to be a 6+, and sulfur in its ion form, sulfide, is a 2-. So when I swap and drop, we're going to start with the lead. The 2 swaps over and down. The 6 swaps over and down behind the sulfur. And then we have to reduce, because these are formula units, the lowest ratio of atoms possible. So my common denominator between these is a 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3, PbS 3. Iron 3 oxide. So iron 3, Fe3+, and then oxide is going to be a 2-. Oxygen is a fixed charge. So when I swap and drop, I get 2 irons and 3 oxygens. Iron 2 oxide. So this iron is a 2+, and oxide is still a 2-. Notice here the numbers are the same, so I simply rewrite my symbols FeO. All right, so I feel like writing the compounds from the name is pretty straightforward because it works out the same way as we have learned for our binary compounds that did not contain a variable charge, but instead had those fixed charges. The difference here is the Roman numerals tell us what the charges up here are that we are going to use. I think it gets a little bit more tricky when you are provided the formula and you have to write the name. Because in this case, we now have to do math. Fluorine is a 1 minus. So we are going to always start with what we know, the fixed charge. Fluorine is a 1 minus. And I have 2 fluorines. So 1 minus times 2 is a -2. Now, we've already seen that ionic compounds are made of ions, but overall neutral. So in order to make this an overall neutral, I need a +2 total charge from the cation, in this case, nickel. How many nickels do I have? I have 1 nickel. So what times 1 is 2? 2. Nickel, 2 fluoride. Nickel, 2 fluoride. So let's do another example. All right, fluoride is a -1, and I have 3 of them. So overall, a -3 from the fluoride. My compound is neutral. So that means chromium must give me a +3 total. How many chromium atoms are there? 1. So what times 1 is 3? 3. Chromium, 3 fluoride. Now these are tricky. These require practice. You have to practice these in order for it to start to make sense. As with a lot of chemistry, practice makes perfect. So let's try another one. All right, sulfur. Sulfur has a 2 minus. All right, it is a fixed charge. It is a 2 minus. And there are 3 sulfurs. So 2 minus times 3 is overall 6 negative parts, but my compound itself overall is neutral. So that means iron must provide me with a +6 total to make my compound neutral. How many irons do I have? The answer here is I have 1. So what times 1 is 6? And the answer is 6. Iron 6 sulfide. All right. CuBr2. Br is a -1. There are 2 of them. So that is an overall -2. My compound must be neutral, which means I need 1 copper. 1 copper to be a 2+. So I need this copper overall to be a 2+. There's only 1 of them. So what times 1 is 2? 2. Copper, 2 bromine. Bromine here is a -1. There's only 1 atom of bromine here. So that's an overall -1. In order to make my compound neutral, copper must give me a +1. I have only 1 copper here. So what times 1 is 1? And that is 1. Copper, 1 bromide. Now, What if you had more than one cation? All right, then this value right here would be however many that is. So each one of these examples, we only had a single cation. So each one of these was a 1. But let's say you had 2 coppers and some other anion, but that was a Cu2. In that case, you would make this a 2. All right, and there's some examples like that in your practice, okay? So what you're going to do now is you're going to go through and you're going to go to that practice and give this a try.